Okay. Now come to face cards. You can see there are different kinds of figure, and you can see a J written, and there's a Q and there's a king. Okay. So this J is actually Jack. So this is called Jack of club. Like this particular card is Jack of club. This is Jack of spade, right? This is Jack of heart, Jack of diamond, like this we name it. And the Q is queen, this queen card. So queen of heart, queen of diamond, queen of spade, queen of club, like that. And king, right? K is king card. So I think this much is enough to get familiar with cards, and you just you need to know that club and spade are actually black, and heart and diamond are red cards, and that's it. It's enough. So total face cards, as you can see, 3 into 4. So we have 12 face cards, okay? And ace cards are 4 in number, and number cards are 9 into 4. That means 36, right?
Yes.
Okay. So let's come to question number 14 now. Do you have NCERT book, Afaf, with you?
Yes, I
Okay,
have.
okay. So read the question in book and then we will solve it here. Now question number 14. One card is drawn from a well shuffled deck of 52 cards, right? So you are drawing one card at random. So what are the possible outcomes? Or you can write total number of cards also here. So Martin, you are picking out one card at random from a pack of 52 cards. So it can be any of the card, right? So the total number of all possible outcomes are 52, right? Okay. Now first, find the probability of getting a king of red color. Okay. So what I need is a king and it should be of red color. So how many cards do I have like this?
26.
No. It should be a king card and it should be red. So I have only two. One is king of heart, right? And the next is king of diamond. That's it, right?
Yeah.
Total king are 4. 2 kings are black and 2 are red. So I need red. So I have only 2, right? So
Yes.
you can write that number of king of red cards are how much? 2. There are only 2 cards. So probability of king of red color is so Afaf, the formula is this: number of outcomes, or you can say number of favorable outcomes. Sorry, number of favorable outcomes, right? And divided by number of possible outcomes, like all possible outcomes, right? This is the formula. So my favorable outcomes are only 2. And the total possible outcomes in this case are 52. So you can bring it to simplest form, that is 1 upon 2 into 2 and then 26. So 1 by 26 is the probability of getting a king of red color.
Excuse me, how did you get 1 by 26?
You just reduce it to simplest form, right? Divide 52 by 2. Oh, yeah, sorry, 52 by 2, right? So 2 into 2, 4 and then 12. So 2 into 6 is 12, right?
Yes.
Okay.
60 face cards.
Okay, face cards, right? Now total outcomes are this 52. So how many favorable outcomes are there?
12.
Yeah, there are 12 face cards, right? So he is like, it is not written that particular color or particular name is not written, only face card is written. And face cards are 12 in number. So my favorable outcomes are 12. It can be any of the face card, right? So the so the probability of a face card is 12 divided by 52. And then you can again reduce it to simplest form, divide this by 2, numerator and denominator. So you get 6 by 26, right? Again, you can divide. So you get 3 by 13. So that's it.
Yeah.
Okay, third, you want to find the probability of a red face card. Okay, so now there's an addition term, red. Okay. So how many number of favorable outcomes in this case?
6.
6, yes. So it is 3 cards of heart and 3 face card of diamond. So possible number of favorable outcomes are 6. So the probability of a red face card will be 6 divided by 52, right? Again, you can divide numerator, denominator both by 2. So you get 3 by 26. Now, fourth, you want the,
1 right.
okay, the jack of heart. Okay, Manha. How many jack of hearts are there?
Ma'am, 1.
1. That's it. So number of favorable outcomes is only 1, right? Of half. So the probability of jack of heart is 1 divided by 52. That's it. And next, a spade. How many spade are there?
13.
Afaf.
13.
Okay. Afaf, what do you think? How many spade are there?
13.
13, right? Mana. So you have to take all spades, whether it's a face card, whether it's an ace card or a number card. It should be spade. That's it. So you number of favorable outcomes in this case are 13. So the probability of a spade will be 13 divided by 52. So 13 into 4 is actually 52. So as you can see in the cards also, 13 into 4, total 52. So it will be 1 by 4. Now sixth also, the queen of diamonds. Okay, how many queen of diamonds are there?
1.
Only one, right? So there's only one queen of diamond out of 52. That's the probability. Sorry. Okay, next question. So I hope you have written it.
Yes, ma'am.
Okay. Question number 15. So 5 cards, right? A 10. So there are 5 cards. One is a 10, right? One is a jack. Then one card is queen. One card is king and ace. of diamonds, and they are all of diamonds, right? Like similar category, but different cards. Are well shuffled with their face downwards. Now one card is then picked up at random, right? So first, what is the probability that the card is the queen? How many number of favorable outcomes in this case?
1.
Yes. Only one, right, Martin? Because there's only one queen.
Yeah, yeah.
Okay. Now before this, you write total number of outcomes or total possible outcomes. Total number of possible outcomes. So when you are picking a card, it can be any card. So there are total 5 cards. So it can be a 10 card, it can be a jack card, it can be queen, it can be king, it can be ace. So the all possible outcomes are actually 5, right? Now your favorable outcome which you want, so you want a queen. So your favorable outcome will only be 1 as there is only one queen. So the probability of getting queen is 1 divided by 5. Now, second part, it's important. Pay attention here. Second part. If the queen is drawn and put aside, right? What is the probability that the second card picked up is an ace? Now, when a queen is picked up and it is kept aside, so how many cards are remaining now?
4.
4, right? So total number of possible outcomes will be how much this time? All possible outcomes will be 4, right?
Yeah.
Understood, Afaf? Because one card we have put aside. Now only 4 cards are left. So all possible outcomes can be 4. Apart from queen, now I can get a 10, I can get a jack, I can get a king, I can get an ace. Mana, is that okay? Okay. Now I want to find the probability of getting an ace. So number of favorable outcomes are how many now? Now only these cards are remaining. One is ace, one is jack, one is king, and one is ace. Sorry, 10. One was 10, right? Okay. Now only these 4 cards, and I want an ace. So there's only one ace among these 4 cards. So my favorable outcome is only 1, correct? I don't want these other kind of cards. I want only ace. And there is only one ace in this in these 4 cards. So my favorable outcome is only 1, correct? So now probability of an ace is 1 divided by 4. Correct? This like part A. Now part B. What is the probability of getting a queen now?
0.
0, right? So now number of favorable outcomes are 0 because there is no queen. So number of favorable outcome is actually 0. So the probability of getting queen is 0 by 4. That is 0. Okay, now next question. So we have done it, but anyway, 12 defective pens are accidentally mixed with 132 good ones. So how many total number of pens are there?
Ma'am, we did this one.
Yeah, because of half has joined today, so I'm just repeating. Only one question. So total number of pens will be now 12 are defective and then 132 are good ones. So these are the total number of cards. So can we add them? 2 and 2, 4, and this is 4, 144, right? It is not possible to just look at a pen and tell whether or not it is defective. Afaf, this sentence is important, right? So that means all the pens are looking same from outside. That means there is no bias of any kind. There is no, there is no indication, there is no hint of any kind. So that means the number of outcomes now will be equally likely. Understood?
Yes.
Okay. So one pen is taken out at random. So it's also written at random. So that means it's a fair selection from this lot. Determine the probability that the pen taken out is a good one. So these are the total number of pens. So I want a good pen. So how many number of favorable outcomes now?
132.
132. So I want only good one and they are 132 in number. So the probability of, you can say the pen is good. So it will be 132 divided by 144. And then you can divide this by 2. So this will be, so it will be 2 into 5 is 10 and then 32. No, what I'm doing, 2 into 6 is 12 and then again 66. 2 into 7 and 2. And then again by 2 you can do 33 and divided by 2 into 3, 36. And then by 3 you can do, so 11 divided by 12. That is the answer. Right?
Yes.
Okay. Question number 17 now. A lot of 20 bulbs contain 4 defective ones. A lot of 20 bulbs. So total number of bulbs are how many?
24.
24.
Read the sentence again.
Now my 2020.
Total number of bulbs are only 20. I mean, the 4 defective are included in this 20, isn't it?
Yes.
So it's not saying that 20 are good bulbs and 4 are defective. A lot of 20 bulbs contain 4 defective. That means the total number of bulbs are 20, correct? And number of defective
Yeah.
ones, you can say that number of defective bulbs is 4. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? So this one is simple. Now total are 20 and my favorable will be 4, correct? So the probability of, you can say the bulb is defective will be, okay. So this 20, that means number of all possible outcomes are 20 in this case, right?
Yes.
Okay. And because there are only 4 defective bulbs, so number of favorable outcomes will be 4. So the probability is number of favorable outcome divided by all possible outcomes. So this will be 1 by 5. Now, what is the probability that this bulb is not defective? So first of all, let us find out how many good bulbs are there, right? So number of good bulbs is will be 20 and minus 4, right? So it will be 16, correct? Oh, sorry. There was something in the question I didn't read. Wait. Suppose the bulb is drawn in, okay, first is not defective and is not replaced. Sorry, I was reading the other question, just wait. Suppose the bulb drawn in first is not defective and is not replaced, okay. Now one bulb is drawn at random from the rest, right? What is the probability that this bulb is not defective? Good. So Martin, now see here, what they are saying is, I think first part is clear, okay? This was simple. Okay. Now what happens is, I have drawn out one bulb. Now it comes out that this bulb is not defective. Clear? That means it's a good bulb. Okay. Now because we have already drawn out one bulb, so how many number of remaining bulbs are there?
19.
19. Understood? Mana?
Yes, ma'am.
Yeah. So now only 19 bulbs are left. Okay, Hamna. Sorry, half. One, because in the first case we have drawn out one bulb. Okay, so that is gone now. Only 19 bulbs are remaining. Okay. And we already know that 4 bulbs are defective in total. Understood? So that means out of
Yeah.
this 19, 4 are defective. So how many not defective bulbs are only 15? Number of bulbs which are not defective will be total 19 bulbs and minus 4. See, the thing going on here is there are total 20 bulbs, right? Out of them, 4 are defective bulbs. So I'm just picking out one bulb. So it can be any bulb, it can be a defective bulb, it can be a good bulb, right? So I picked out one bulb and that bulb came out to be a good one. So now because already I have picked out one bulb, so remaining is 19. Now actually those 4 defective bulbs are also present in the 19. Okay. So that means the not defective bulbs will be 15. Understand?
Yeah, ma'am.
Okay. So therefore probability of bulb is not defective will be 15 and divided by 19. Okay, now next question, 18. A box contain 90 discs, okay, which are numbered from 1 to 90, right? If one disc is drawn at random from the box, random means it's a fair selection. Every outcome is equally likely here. So if one disc is drawn at random from the box, find the probability that it bears a 2-digit number, right? So total number of discs are how many? Total number of discs is equal to 90. That means total outcomes are 90. All possible outcomes are 90, correct? Okay. Now I want to find the probability that it bears a 2-digit number. Now from 1 to 90 if I write, so 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 10. So that means these 9 numbers I have to subtract because they are not 2-digit number, right? And the rest of the number are my favorable outcome. Is this clear?
Yeah, ma'am.
Okay, so first case, number of favorable outcomes are how many? Will be total 90 minus 9. Understood? So it will be 81. So the disc which are containing numbers from 1 to 9, so we have, those are not my favorable outcomes. So the probability of a 2-digit number, you can say, a 2-digit number will be favorable outcomes are 81, total
By
the possible outcomes are 90. And it is divisible by 9, so 9 into 9 is 81 and 9 into 10 is 90. Second, so in every case, first of all, you write your favorable outcomes, right? How many number of favorable outcomes are there? Second case, a perfect square number. Very good. So from 1 to 90, we have to see how many perfect square numbers are there, right? So first is 1, because 1 into 1 is 1, right? Then 2 into 2, 4. 3 into 3 is 9. 4 into 4, 16. 5 into 5, 25. 6 into 6, 36. 7 is 49. 8 into 8 is 64. 9 into 9 is 81. And 10 into 10 is 100. So which is actually going out of 90, right? Within 90, we have to see. Okay. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 perfect squares, right? So number of favorable outcomes are 9. Is this clear, everyone?
yes.
Yeah. So you can mention these also like in your copy so that you can remember. So number of favorable outcomes are 9. So obviously probability of getting a perfect square is now favorable are 9 only out of 90. So it will be 1 by 10. Third, a number divisible by 5. Okay, so the first number will be 5, right? And then 10, then 15 and 20, then 25 and 30, 35 and 40, then 45, 50, 55, 60, 65, 70, and then 75, 80, and then 85 and 90. How many numbers are there? Yes,
18.
18. Yes. So you can just write them like this, or you can do it in your mind, in one row. As you can see, there are 2 numbers are falling, correct?
Yeah.
And because it's only up to 90, so you can simply do 2 into 9, that is 18. Is this clear, everyone?
Yes, ma'am.
Yeah, so that way also you can do. So number of favorable outcomes are how many? 18 are there. So probability of what do we write? A number divisible by 5.
18 by 90.
Yes. So it will be 18 and total possible outcomes are 90. Again, you can divide by 9. 9 into 2, 9 into 10,
1
and
by
then
5.
1 by 5. Yes. So it's an easy chapter actually and scoring chapter. Just read the questions carefully. That's it. Okay. Next question now. Because there are not many formula to remember, right? It's pure logic. Next, a child has a die whose 6 faces show the letters as given below. So these are the 6 die. 3, 4, 5, and 6. And these are the letters A, B, C, D, E, and then one more A. A die is thrown once. Okay, what is the probability of getting A and D? First of all, what is the probability of getting A? Now, okay, before this you write a die is thrown, right? So you can get any face. So total possible outcomes are how many? Martin, is it 5 or is it 6?
What, ma'am? It's
How
6.
many possible
6.
outcomes? Yes.
6.
So we don't know, like we can get any of the face of the die, right? There are 6 faces. So possible outcomes are 6. Okay. Now first case. I want A, right? So how many number of favorable outcomes are there?
2, ma'am.
2, because yes, because there are 2A, right? So my both, like I can have any of the A. I can have the first A, or I can have this A which is on another face. So both are my favorable outcomes. So the probability of getting A is 2 by 6. That is 1 by 3. Now I want D, right? So D, number of favorable outcomes are how many?
1.
Only 1, because there's only one D. And I want that, okay? It's only 1. So probability of getting D is 1 divided by 6. And in every question, you can mention you have to mention the formula also, because I'm not writing it again and again. So in case you did some mistake in the calculation, at least you can get marks for the formula, right? So please write that probability is equal to number of favorable outcomes divided by number of all possible outcomes. Next question, number 20. Suppose you drop a die at random on the rectangular region shown in figure. Okay, what is the probability that it will land inside the circle with diameter 1 meter? Okay, it's interesting, isn't it? So there is a rectangle actually whose dimensions are given 3 meter and 2 meter. And then there's a circle of diameter 1 meter, right? So the radius is half meter. Okay. Now you are throwing a die. So he is asking that what is the probability that the die will fall inside this circle? What do you think? How can we do this question? Any idea?
We will take the perimeter of the rectangle.
Okay, what will be like, how will you relate it with probability?
And like there's like a chance of that falling into the rectangle. We can take that.
Yeah, so not the perimeter, actually area, Martin,
Yeah.
because inside space we want, right? Okay, now try to understand. I want to find the probability that the die has to fall in this circle, right? So that means out of this complete area, only this area is my favorable outcome.
Yeah.
Getting it, everyone?
Yeah.
Yeah. And the
So
total area,
we add.
yeah, and the total area of the rectangle is the possible, like possible, you can say all possible outcome, right? The die can be anywhere. It can be here, it can be here, it can be here, anywhere. So all the full area of the rectangle is the possible outcome. And my favorable outcome is only this one, this much. Are you able to relate it now?
Yes, ma'am.
Okay, so first of all, find out the area of rectangle, and then we will write it in the probability language, right? So area of rectangle is equal to 3 meter multiplied by 2 meter, that is 6 meter square. And also find the area of the circle. Area of circle which is pi r square. So 22 by 7 or into, I think we can leave the answer in terms of pi also because it's not mensuration, so we don't want exact measurements. Let us leave it in terms of pi. So pi into radius will be half meter and then whole square, correct?
Yeah,
Because
R
diameter
square.
is
Yeah,
diameter is 1, so radius is 1 by 2. So it will be pi by 4 meter square. Is this correct? 2 square is 4. So now in terms of probability, you write it again. That, how will you write? Number of, in place of number, this time we can write, how we will write it?
24 pi by. So
No, that will be the answer. I was just trying to write it in terms of probability. You can write like this, like just for in case you forget, so you will be able to recall. So the possible area outcome, you can say, right, is actually the area of the rectangle, which is 6 meters square, right? And your favorable area here is
oh,
actually only the circle, which is pi by 4 meters square. So that means the probability of mm, the die drops inside the circle. So I want this probability. So that means pi by 4 meters square and then divided by 6 meters square. Is this correct? And then meter square will cancel out and you can make a 1 here. So 1 into pi and 4 into 6. So that is pi by 20. So Afaf, I think you know, when you divide fraction by fraction, so that means, so the outer numbers are actually multiplied together and they go in the numerator. The inner ones, they come in the denominator. So they are written like this.
Yes, I know.
Okay, next question now. Question number 21. A lot consists of 144 ball pens, okay, of which 20 are defective. So total number of pens are how much?
144.
144.
Okay, so total number of pens are 144. 20 are defective. So number of defective pens,
20.
yes, it's 20. And the others are good. So, okay, fine. Noori will buy a pen if it is good, but will not buy if it is defective. Okay, the shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? So that means you want to find the probability of a good pen, right? So we can find the number of good pens first of all. So that means total pens minus 20, correct? So it will be 124, right? Okay. So, okay, now Noori is actually, if it is a good pen, so she will buy it, right? If it is a defective pen, so she will not buy. This is the case here, right? Noori will buy a pen if it is good, right? So now the shopkeeper is drawing out one pen at random, and what is the probability that she will buy it? That means you have to find the probability of a good pen, correct? So the probability of good pen is equal to total good pens are 124. So your favorable outcomes are 124 and all possible are 144. Now divide this by, let's say by 2 first of all. So 2 into 6 and then 2 into 2, 2 into 7 and 2 again, 2 into 3 and 2 into 3, 36, and again, yeah, I think that's it, 31 by 36, okay? So this is the probability that she will buy it, or you can say therefore probability Noori will buy is 31 by 36. So in that terms also you can write. Okay. Now second part, that she will not buy it. That means you want probability of defective pen, correct?
Yes, ma'am.
Okay. So it can be done both ways. Like, okay, so the probability of defective ones will be 20 and by 144. Now what is the answer? 4 into 5 is 20 and 4 into 3 is 12 and 24. 5 by 36, right? So Afaf, there is one thing here which I want to tell you. For an event E, right? You can note it down. For an event E. So the probability of, how do we write it? E and plus the probability of, probability of not E is actually equal to 1, correct?
Yes, ma'am.
Okay. So let's say E is your, E is the event that she is buying, right? Let E is the event that Noori will buy, right? So the second case can be done directly. So that means probability of not buying, right? Can be done like 1 minus probability of buying, correct? So if you do 1 minus, and this is the probability of buying, which is 31 by 36. So you will get the same answer that you can check. Now you take LCM. So it will be 36. So it will be 36 minus 31, and this will be again 5 by 36. Is this understood?
Yeah.
So this is important. Above, please make it a box and write where E is any event. So the probability of like event E occurring and then plus the probability of not E is actually equal to 1. See, it's obvious, right? If something is happen or it will not happen. So there are equal chances. So might be not equal, but anyway, the sum will be 1 always. Like in some cases it is happening, then obviously in other cases it is not happening. So if we add all the probability, it will come out to be 1. Mana, is this understood?
Yes, ma'am.
Next question, number 22. 2 die, one blue and one gray, are thrown at the same time. So one die is blue and one die is gray. Complete the following table, right? So there's a table where event, what is the event? Sum of 2 dice. Good. And then you have to write probability here. Right? Okay, so first is given that sum is 2 and the probability is 1 upon 36. Now, okay, I think before doing this question, let me tell you one thing. Then we will come back to a question. So far, we were dealing with questions where we were tossing only one coin or we were tossing only one dice, right?
Yeah.
Now, if I toss 2 die together, like at the same time, so let's see how many outcomes will be there, right, Mana?
Yes, ma'am.
2 dice together if I'm throwing. So you know on a dice there are numbers from 1 to 6, right? Okay. So let's see how many possible outcomes are there. Let's say on the first die I get 1, right? And on the second die also I get 1. So this is one possible combination, right? Then on the first die I still have 1, but on the second die I have 2. I have 1 and the second die 3. First die 1, second die 4. And then first die 1, second die 5. And first die 1 and second die 6. This can be right. Now, on the first die I get 2 and then on the second die I get 1. So 2 and 2, then 2 and 3, then 2 and 4, 2 and 5, and then 2 and 6, right? Now on the third, first die I get 3, second die I get 1. So I can write up to like last 3 and 6. Similarly, on the first die I get 4, second die I get 1, and then it will be 4 and 6, correct? Then 5 I get on the first die, and 1 I get on the second die, and then, I mean, you can complete it, okay? I'm skipping. And then 5 and 6. And the last combination will be on the first die I'm getting 6, second die I'm getting 1, and similarly first die 6, second die 2, first die 6 and 3, 6 and 4, then 6 and 5, and the last combination both dies 6 and 6. How many combinations are there? So this side also 6, right? And this side also
36 combination.
So 6 into 6. So there are 36 possible outcomes.
Yeah.
Understood, Mana?
Yes.
Yes, ma'am.
Okay. So it's time for my next class now. So from this question onwards, I'll take in the next class.
All right.
Just 2 questions are remaining. Yeah, right. Okay. Please practice some extra questions also from some other books. Okay, now you can leave.
Yeah, thank you, ma'am.
Okay, bye.
Thank you, ma'am.
Yes, Harsha, can you hear me?
Yes, ma'am.
Okay, Amna, Sarah.
Yes, ma'am.
Okay, up to which question we did in the last class? I think up to question number 13 we have done, right?
Yes, ma'am.
Okay. Sarah, you were not there, right?
No, ma'am.
Okay. So Sarah, I'm doing probability. So for the time being, you can just note down one formula for probability. And then I think you can go to the recordings of the previous class and that will help you. It's a small chapter. So
Okay, ma'am.
E is like any event, okay? Any event. Event is like I'm tossing a coin, right? So I'm getting a head. So getting a head is an event. Getting a tail is an event. So I want to find the probability of this particular event. It can be any event. So it is equal to like number of favorable outcomes, or you can see number of outcomes favorable to E, and then divided by number of all possible outcomes. Right? Okay. Now, next question number 14 is actually based on cards. So again, I just want you to have a look at cards. So this is a pack of cards, right? So did I think I gave this in the last class also, right? The introduction of cards. Harsha?
No, ma'am, you didn't.
No, okay. Right. So this is a pack of card, as you can see. Now pay attention here. So first of all, you can see there are numbers. On the first, it is A is written, right? Not 1. A is written. Then you have numbers 2, 3, 4 up to 10. And then there are some special letters J, Q, and K. So these first A is actually called ace cards, right? Not 1, it's ace cards. Then starting from 2 and then up to 10, they are called as number cards. Sarah, yes?
Yes, ma'am.
Okay. And these, which you can see, they have some pictures on them. They are called as face cards. Right? So you can see there's a J written here. So this J is actually called Jack. The Q is called Queen. And the K is King. Okay.